Welcome back. We are still on the topic rigid motion and transformation. In the previous video, we solved some questions on translation of a point in the x and y plane. In this video, we are going to solve a likely examination question on translation of a point in the x and y plane. The question for this video is A. Using a scale of 2 centimeters to 2 units on both axes, draw on a graph sheet two perpendicular axes OX and OY for the interval x is between -10 and 10 and y is between -12 and 12. B. Draw triangle EFG with vertices E that has the coordinates -2, 7, F that has the coordinates 6, 7, and G that has the coordinates -2, 2. C. The image triangle E1F1G1 of triangle EFG when it is translated by the point 4, 5, where E maps to E1, F maps to F1, and G maps to G1. So we are going to use a scale of 2 centimeters to 2 units to number our x-axis from -10 to 10 and our y-axis from -12 to 12. Then we draw the triangle EFG and the coordinates of the vertices of the triangle has been given to us. After that, we use the translation vector 4, 5 to translate the triangle EFG so that we get the image triangle E1, F1, G1. Now, in order to translate triangle EFG, we have to translate each of the coordinates of the vertices of triangle EFG. So we use the translation vector 4, 5 to translate the point E with coordinates -2, 7 to get E1. Then we use the translation vector 4, 5 to translate the point F with coordinates -6, 7 to get the image F1. Then we use the same translation vector 4, 5 to translate the point G with coordinates -2, 2 to get the image G1. After that, we join the points to form the image triangle E1, F1, G1. So let's start. We have our graph sheet here. This will be my x-axis and this is the y-axis. The scale is 2 centimeters to 2 units. So we number the x-axis from -10 to +10 and the y-axis from -12 to +12. So we have answered the first part of the question. We are now moving on to the second part. Draw triangle EFG with coordinates E, F, G, and the coordinates of each of the vertices has been given to us. So let's go onto our graph sheet. We are going to draw the triangle EFG and we have the coordinates of E, F, and G. So you can plot them and join them to get the triangle EFG. E has the coordinates -2, 7. So -2 on the x-axis, 7 on the y-axis will be at this point. F has the coordinates -6, 7. So -6 on the x-axis, 7 on the y-axis will be at this point. And G has the coordinates -2, 2. So -2 on the x-axis and 2 on the y-axis will be at this point. Now we join these 3 points to get the triangle EFG. We have to indicate the coordinates of each of the vertices. So this is the vertex E with coordinates -2, 7. This is the vertex F with coordinates -6, 7. And this is the vertex G with coordinates -2, 2. Let's move on to the last part of the question. We are going to find the image triangle E1, F1, G1 of triangle EFG when it is translated by the point 4, 5, where E maps to E1, F maps to F1, and G maps to G1. As I've already explained, we are going to use the translation vector 4, 5 to translate E in order to get E1, we translate F in order to get F1, and then we translate G in order to get G1. So let's do that. The translation vector is 4, 5. The coordinates of E is minus 2, 7. The coordinates of F is minus 6, 7. And the coordinates of G is minus 2, 2. We know that image is equal to point plus translation vector. So if we want E1, which is the image of E, we have to add the point, which is minus 2, 7, to the translation vector, which is 4, 5. So the image of E, which is E1, will be equal to minus 2, 7 plus 4, 5. And this will give us minus 2 plus 4 will give us 2. 7 plus 5 will give us 12. So the coordinates of E1 will be 2, 12. So E with coordinates minus 2, 7 will give us E1 with coordinates 2, 12. Let's move on to F. F has coordinates minus 6, 7. Remember that image is equal to point plus translation vector. So the image of F, which is F1, will be equal to the point minus 6, 7 plus the translation vector 4, 5. Minus 6 plus 4 will give us minus 2. 7 plus 5 will give us 12. So point F with coordinates minus 6, 7 will give us F1 with coordinates minus 2, 12. Lastly, we move on to G. G has the coordinates minus 2, 2. Image is equal to point plus translation vector. So the image of G, which is G1, will be equal to the point G minus 2, 2 plus the translation vector 4, 5. Minus 2 plus 4 will give us 2. 2 plus 5 will give us 7. So point G with coordinates minus 2, 2 will give us G1, which is the image of G, and G1 has the coordinates 2, 7. So we now have the coordinates of E1, F1, G1. So we can draw triangle E1, F1, G1. We already have triangle EFG here. We are going to draw triangle E1, F1, G1. We have the coordinates of the vertices, so we can easily do that. E1 has the coordinates 2, 12. So 2 on the x-axis, 12 on the y-axis. And we have that here. F1 has the coordinates minus 2, 12. Minus 2 on the x-axis, 12 on the y-axis. We have that here. And G1 has the coordinates 2, 7. 2 on the x-axis, 7 on the y-axis. We have that here. So we join them to form the triangle E1, F1, G1, which is the image of the triangle EFG, after the triangle has been translated by the translation vector 4, 5. Let's write the coordinates of each of the vertices against it. The coordinates of this one is 2, 12. So E1 is 2, 12. The coordinates here, that is F1, is minus 2, 12. And the coordinates here, that is G1, is 2, 7. The scale we used on the graph sheet is 2 centimeters to 2 units on both axes. So after translating triangle EFG with the translation vector 4, 5, we get the image triangle E1, F1, G1. Now look at something very interesting here. The translation vector we used is 4, 5. It means that if you want to translate a point, we move 4 units in the positive direction along the x-axis. We have seen that on the x-axis, the positive direction is towards the right. The y component of the translation vector is 5. It means that we have to move 5 units in the positive direction along the y-axis. We know that along the y-axis, moving upwards means that we are moving in the positive direction. So to use this translation vector, we have to move the point 4 units towards the right along the x-axis, then 5 units upwards along the y-axis. So if we take the point G with coordinates minus 2, 2, to find the image of G, which is G1, we have to move the point G 4 units towards the right along the x-axis, then 5 units upwards along the y-axis. The scale we are using is 2 centimeters to 2 units on both axes. So it means that 1 centimeter is 1 unit. So when we move point G from this point to this point, we have moved it 1 unit. When we move it from this point to this point, we have moved it another unit. When we move it from this point to this point, we have moved it another unit. So let's try that and see. We are moving point G 4 units towards the right along the x-axis, then 5 units upwards along the y-axis. So we move it to this side, we have 1 unit. Move it to this side, we have 2 units. This side, we have 3 units. And this side, we have 4 units. So you have moved it 4 units towards the right along the x-axis. Let's move it 5 units upwards. Move it from this side, we have 1 unit. Move it to this side, we have 2 units. Move it to this side, we have 3 units. Move it to this side, we have 4 units. And move it to this side, we have 5 units. So you see that we are getting G1, which is the image of G, exactly as when we used the formula. You can try for the other points and you see that all of them works. So this is how to use a translation vector to translate a point from one point to another in the x and y plane. When we translated triangle EFG to get a triangle E1F1G1, the size of the triangle did not change and the shape of the triangle did not change. It only changed in position. Because the size did not change and the shape did not change, we can say that translation of a point or an object in the xy plane is an example of a rigid motion, because as we learned in the introductory video to this chapter, when an object undergoes a rigid motion, it does not change in size and does not change in shape. It only changes in position. When you translate an object from one point to another in the xy plane, it does not change in size, it does not change in shape. It only changes in position. So we can say that translation of an object in the x and y plane is also an example of a rigid motion. In the introductory video to this chapter, we said that we will consider 4 types of transformations. So far, we have considered reflection and translation. In the next video, we are going to learn about rotation. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to rotate a point from one position to another in the x and y plane. Bye bye.